Now we're going to introduce some properties of logarithms. Now, go ahead and learn these because in the next section I'm going to give you like a bazillion more, so if you don't learn these, it's just going to make more work for you later. So the nice thing about logs is because logs and exponents, remember, they're inverses of each other. So a lot of the exponent laws look really, really similar to the log laws, except they're just kind of organized differently. So let's see if we can derive some of them. So say I have b to the first equals, what's b to the first? B to the first equals b, right? Yes. Alright, so let's convert this to a log. So working from left to right, the first number I see is log base b. Log base b. Hop over and get that b. Log base b of b is 1, right? Log base b of b is 1. Log base b of b is 1. Believe it or not, that's a property of a logarithm. So the idea is, if I had, say I give you 3 times log base 6 of 6. Well, now you could say, okay, so that's 3 times, let me see, this number and this number, they're the same. So if those two numbers are the same, like they are here, b and b, those two numbers are the same, that means that the whole log is worth 1. So it's kind of neat. When those two numbers are the same, the whole log value is 1. So 3 times log base 6 of 6 is just 3 times 1, or 3. Alright, try another one. What is b to the 0? Hopefully you got this. Anything to the 0 is not 0. It's 1. So now working from left to right, I've got log base. The first number I see is b. Log base b of 1 is 0. This is also a log rule. Log base b of 1 is 0. So log base anything. So log base 7 of 1 is 0. Log base 9 of 1 is 0. Log base 1.0, what is that going to be? A 6.3 of 1 is 0. Log base anything of 1 is 0. So if I give you a problem like 3 times log base 6 of 1, okay, well that's log times the log of any base, the log of 1 is 0. So that would be 0. Alright? Now these next two are a little goofy to derive a little bit. This is a really loud subway. So, say I have, I'm going to start with this one. Say I have b to the x equals b to the x. Not particularly profound, right? b to the x is b to the x. Alright, well let's convert it to a log. So log of, log base, the first number I see is b. Log base b of, now I'm going to take this whole thing, log base b of b to the x equals log of base b of b to the x equals x. That's your other one. Say I have log base 6 of 6 to the 32. When these numbers are the same here, my answer is going to be that exponent. When the log base and the log argument are the same, my answer is going to be that exponent. The last one like this we're going to do is to say log base b of x is equal to log base b of x, and we're all going to withhold our shock. And I'm going to go from left to right. And I'm going to convert this to an exponent. So the first number I see is a b. So b, I'm going to hop over and pick that up. So b to the log base b of x. I'm going to hop back. Make that blue so you see where it comes from. Log base b of x. And then I'm going to hop back and get the x. That was a little funky, so I'll rewrite it. B to the log base b of x is x. So if I have 6 to the log base 6 of 19 if the base of the exponent and the base of the log are the same, then the answer is going to be that exponent right there. Kind of cool? Yeah, I thought you'd think so. Actually, these are really, really good to know because these are super fast problems. These are problems that you're going to get on the test, and I'm going to assume they don't take you any longer than 20 seconds to work out. So I'm going to put these on here. So see if you can get these worked out. You should almost be able to answer them as fast as I'm writing them. And if you're not there yet, that's okay. Just give me a little while. But in general, these are supposed to be pseudo gimmies. Like this problem, it looks really, really, really hard, but it's actually not. It's very, very direct. So let's start at the beginning. Log base 7 of 7. Remember, if the bases are the same, so the answer is 1. The log of anything, base anything, the log of 1, is always going to be 0. When the bases are the same, again, I'm going to go with the exponent. And when the bases are the same, again, I'm going to go with the exponent. So, this problem, especially the second two, they look really, really hard. And you'd be like, okay, so I need to take 4 and raise to the 5th power. You don't need to do that. You just need to recognize the property and basically write the answer almost like you're taking dictation.